9, 8, 7, 6, 5.
Newton's third law has just been shaken to its core. An ex-NASA engineer claims to have built a machine that lifts itself against gravity without fuel. For decades, the electromagnetic drive was dismissed as impossible, every experiment failing. But now, with no rockets, no flames, no exhaust, only electricity, he says space travel could be revolutionized. Is this a bold leap into the future, or just another elaborate hoax? And how could the third law of motion be broken? Join us as we uncover the truth behind the fuel-free space drive. Charles Buer, once an engineer at NASA, worked on important projects like the Space Shuttle, the Hubble telescope, and the International Space Station. His job was to help make sure rockets worked safely and didn't fail unexpectedly. Now he leads a team at Exodus Propulsion Technologies, a private company chasing a bold goal: building a spacecraft engine that doesn't need any fuel. If they succeed, space travel could change forever. Traveling to the moon, Mars, or even farther would no longer require carrying large amounts of fuel. Instead, Buer and his team say they have built a machine that can move itself without throwing anything out to push against. This idea goes against one of the most basic laws of physics, Newton's third law, which says that for every action, there is an equal and opposite reaction. Typically, rockets push fuel backwards to move forward. This also follows the rule of momentum conservation, where moving something forward means something else moves backwards to balance the motion. But this new device creates motion without pushing against anything. It's like a balloon that flies forward without releasing air. If true, it would mean there is a force in nature that science has never discovered before. Buer calls this mysterious effect the new force. Their machine works using electrostatics, the forces created by electric charges. The test device is small, about 30 grams and the size of a deck of cards. Yet it can produce thrust using electric fields, which are invisible forces created by electricity. Two key things make this happen. First, there must be an uneven electric pressure across the device, similar to how air pressure can be higher on one side of an object than the other. Second, the electric field must spread out unevenly, not in straight lines, but like rays of sunlight or spokes on a wheel. When these conditions are met, the device pushes against itself and moves forward. If this works as claimed, it could change everything we know about movement and open new possibilities for space travel. Initially, the newly discovered force was barely perceptible, producing minimal thrust and no noticeable sound. However, with successive improvements, the results began to change significantly. By 2023, the team reported generating sufficient thrust to counteract Earth's gravity. One of the most perplexing observations, according to Buer, is that in some cases, the thrust continues even after power is switched off, provided there remains residual charge within the materials. This phenomenon suggests the presence of an entirely new physical effect, beyond current scientific understanding. Such claims naturally raise concerns within the scientific community, as they challenge established principles. Buer acknowledges that this research is in its early stages. His team has published their findings and secured a patent. The company includes experts formerly employed by NASA, Blue Origin, and the U.S. Air Force, who have been investigating advanced propulsion concepts for decades. Buer presented this work at the Alternative Propulsion for Exploration Conference, a forum for researchers exploring unconventional propulsion technologies, including concepts such as warp drives and anti-gravity. The project remains active and under development. Understandably, the work has sparked controversy and skepticism among scientists who caution that unnoticed errors may exist. To validate the results, the team plans to test the device in space. Success in a microgravity environment could profoundly transform the future of space travel. Surprisingly, Charles Buer's work at Exodus Propulsion Technologies is not the first attempt to challenge Newton's third law of motion. In mainstream physics, devices that claim reactionless propulsion are placed in the same category as perpetual motion machines. concepts that, by every experimental measure, cannot exist in nature. For this reason, such claims are almost always dismissed by physicists as pseudoscience. One of the most famous of these ideas came from British engineer Roger Scheuer in the early 2000s. He called it the M-drive, short for electromagnetic drive, a conical resonant cavity that, he argued, could produce thrust toward its base without expelling propellant. To develop the concept, Scheuer founded Satellite Propulsion Research Limited, securing a UKS MART award grant to support his work. His first public prototype appeared in late 2002. Scheuer reported that it generated 0.02 newtons of thrust using an 850-watt cavity magnetron. The device, however, ran only briefly before overheating destroyed the magnetron, and crucially, no detailed plans or replicable data were ever released. A few years later, he introduced a water-cooled version he claimed offered better performance, with ambitions to create a space-ready model and even a superconducting variant. Neither of those projects materialized. Despite this, the M-drive gained media attention. In September 2006, New Scientist ran a cover story portraying it as a potentially viable technology and featuring voices supportive of Scheuer's vision. That coverage drew sharp backlash from the scientific community. Science fiction author Greg Egan, backed by physicist John Baez, criticized the article for meaningless double talk that glossed over the central problem, the apparent violation of momentum conservation. In their view, the magazine risked undermining public understanding of science. The criticism prompted a partial acknowledgement from New Scientist editor Jeremy Webb, who conceded they should have been clearer about the conflict with established physics, and noted that some experts had refused to comment because of the controversy. Still, Webb defended publishing the story, arguing that Scheuer's ideas could be tested and that only a real spaceflight trial would reveal whether they were groundbreaking or purely speculative. Not everyone shared the optimism surrounding Scheuer's work. The former technical director of EADS Astrium dismissed both his theoretical framework and experimental evidence as fatally flawed, making it clear the company wanted no association with the project. Physicist Paul Friedlander went further, pointing out that if no mass leaves a device, its center of mass cannot accelerate, an outcome guaranteed by the conservation of momentum, a principle confirmed for over a century. Any thrust Scheuer thought he had detected, Friedlander suggested, was probably the result of calculation errors amplified by unrealistic scaling. Despite these doubts, Scheuer continued to court interest from major aerospace players. The UK's Department of Trade and Industry granted his company, Satellite Propulsion Research Limited, an export license to share the M-drive with Boeing in the United States. Scheuer later recounted how, in late 2008, he presented his work to Boeing engineers, claiming that by the following year the company had shown interest. He said SPR even built a thruster, producing 18 grams of thrust, and shipped it to Boeing for evaluation. Yet whatever promise the talks once held soon faded. Boeing never licensed the technology, and communication between the two parties ceased. A few years later, Boeing confirmed publicly that its Phantom Works division had once explored unconventional propulsion concepts, including the M-drive, but had long since abandoned them. The statement left no ambiguity. Phantom Works was no longer working with Scheuer and had no plans to revisit the idea. Scheuer, however, remained undeterred. In 2014, he introduced designs for what he described as second-generation M-drive systems at the International Astronautical Congress. These concepts, published the following year in Acta Astronautica, sketch possibilities for superconducting, resonant cavities, and multi-cavity thrusters. Yet no working first-generation prototype had ever been demonstrated, and his new proposals came without detailed schematics. 2 years later, he sought to advance his work through fresh patents and by founding a new company, Universal Propulsion Limited, in partnership with the UK aerospace firm Gilo Industries Group. Meanwhile, across the Atlantic, American engineer Guido Fetta advanced a concept known as the Kenny Drive, a variant of the M-drive that employed a pillbox-shaped resonant cavity. In 2016, NASA's Advanced Propulsion Physics Laboratory, EagleWorks, led by Harold White, published a paper in the Journal of Propulsion and Power, reporting a small positive thrust measurement. The announcement drew immediate attention, but quickly met the same skepticism that had accompanied earlier claims. In China, Yue Chen of the China Academy of Space Technology also revealed that his team had developed and tested M-Drive prototypes, with plans for in-orbit trials to assess performance in the vacuum of space. Yue Chen told Science and Technology Daily that their EM-Drive devices' measured thrust fell between the micronewton and millinewton range, levels far below what would be required for conclusive demonstration. Chen acknowledged that achieving a meaningful test would require scaling up to at least 100 to 1,000 millinewtons of thrust. After 2017, no further updates were made public. Around the same period, Martin Tajmar's group at the Dresden University of Technology in Germany began its independent testing. Public curiosity remained high, but within the scientific community, caution prevailed. Preliminary results from White's lab led some media outlets to declare the M-Drive validated by NASA, a characterization many researchers condemned as misleading and premature. That same year, Feta announced a plan to launch a CubeSat fitted with his drive for a 6-month orbital test, though no subsequent results were reported. By this point, the push for independent verification was well established. Since 2008, numerous teams have attempted to reproduce the reported thrust from the Eaglework report, with little success. At Northwestern Polytechnical University in Xi'an, physicist Wan Yang dedicated 4 years to the effort without achieving repeatable measurements. The most promising early result from Yang's group was later traced to an experimental error. Tajmar's investigation suggested that unaccounted sources of noise and error could explain all apparent thrust reports. Experimental errors in these tests generally fell into 4 main categories. The simplest explanation was that all observed thrust was an artifact of measurement noise, particularly when large energy inputs were used to detect extremely small thrust levels. In such conditions, the background signal could easily overwhelm or distort the actual measurement. The most significant error source appeared to be thermal expansion of the thruster's heat sink, which altered the system's center of gravity and caused the resonant cavity to shift. Harold White's team attempted to model this effect by combining theoretical, thermal, and impulsive thrust displacements. While they considered this their most scrutinized variable, they admitted the thermal issue could not be fully ruled out. Critics, including Mark Millis and George Davies, argued that Eagleworks' method lacked sufficient mathematical and empirical support. The paper's thermal model relied on assumed waveform shapes rather than direct time-correlated temperature and displacement data. It also classified all noise as thermal, ignoring other possible influences such as chamber wall interactions, forces from power leads, or mechanical tilt. The absence of a clear thrust model left the data open to multiple interpretations, preventing a definitive conclusion. White suggested future trials using a Cavendish balance, which would allow larger angular displacements, making any genuine thrust more distinguishable from thermal effects. A space-based test, he noted, would also remove the center of gravity problem. Tajmar's group later employed a Cavendish balance and concluded that earlier results were entirely due to thermal artifacts. Additional error sources included electromagnetic interactions. Significant electromagnetic inputs could induce forces between power lines, between the apparatus and ambient magnetic fields, or between the device and the walls of the test chamber. Yang later reported that such an interaction with Earth's magnetic field had produced the false thrust signal in her 2012 study. Tajmar examined possible Lorentz force effects in Eagleworks configuration. White countered that significant wall interactions would require a precise resonance coupling between the cavity and the chamber, and that the high operating frequencies made this unlikely except under specific geometric conditions. However, he acknowledged that thermal expansion could alter the cavity's geometry and thus its resonance. To maintain resonance, Eagleworks used a phase-lock loop system, assuming this eliminated major wall coupling effects. Despite repeated claims of impending breakthroughs, no independent evidence has emerged to confirm that an M-Drive or any similar propellantless propulsion system has been tested in space. Since 2016, several groups have announced fundraising campaigns and outlined plans for orbital trials. Yet as of 2025, none have published technical results or operational data to verify those tests. In 2023, a new entrant, IVO Limited, announced it was developing a related drive, with plans to test it in orbit aboard a CubeSat later that year. The proposal generated brief interest but ultimately did not proceed, and no data was released. While debate continues over the plausibility of the M-Drive, a radically different propulsion concept, Breakthrough Starshot, is already in active development. Announced in 2016 by Yuri Milner, Stephen Hawking, and Mark Zuckerberg, this research initiative seeks to demonstrate a proof-of-concept fleet of light-sail-driven interstellar probes known as starships. Its ultimate goal is to send a mission to the Alpha Centauri system 4.34 light-years away within a single human lifetime. The initial mission concept targets Proxima Centauri b, an Earth-sized exoplanet in its star's habitable zone. Traveling at 15 to 20% of the speed of light, a starship could make the journey in 20 to 30 years, with an additional 4 years for the return signal to reach Earth. At such velocities, the encounter would be a high-speed flyby, capturing images and scientific data in a brief observational window. The design draws heavily on concepts from A Roadmap to Interstellar Flight by Philip Lubin of UC Santa Barbara. In Starshot's plan, a mothership would deploy about 1,000 starships into high Earth orbit. Each probe, no more than a centimeter in size and weighing just a few grams, would be propelled by a multi-kilometer phased array of beam-steerable lasers on Earth, delivering up to 100 gigawatts of coherent optical power. 10 minutes of continuous illumination would accelerate each craft at roughly 100 kilometers per second square to its cruising speed. Early designs envisioned a 4x4 meter sail, but later studies suggest a 5-meter circular version could reduce system costs. Reaching Proxima Centauri b with sufficient resolution to capture surface features would require each probe to pass within 1 astronomical unit of the planet. The use of a swarm provides redundancy against losses from collisions with interstellar dust, which, according to a 2016 study by Thiem Hoang and colleagues, may be less destructive than initially feared, but could still degrade sensors over time. Photon propulsion, however, demands extreme energy. Even a 1 gigawatt laser produces only a few newtons of thrust, making ultra-low spacecraft mass essential. Every component, from cameras and processors to the communications laser and sail, must be miniaturized and able to endure intense acceleration, deep space vacuum, cryogenic temperatures, and constant impacts from high-speed particles. Delivering the necessary optical power over interplanetary distances poses its engineering hurdles. Atmospheric turbulence may require that the main laser array be based in space, and accelerating a 4-meter sail to 0.2 times the speed of light would demand coherent optics on the order of 3 kilometers in diameter, most likely implemented as a modular phased array. Achieving this will require breakthroughs in at least a dozen existing technologies. Progress toward this vision began in July 2017, when precursors to the Starship, known as Sprites, were launched aboard India's Polar Satellite Launch Vehicle. In 2018, 105 more Sprites were delivered to the International Space Station on the KickSat-2 mission, deployed on March 18, 2019, and successfully transmitted data before burning up during re-entry 3 days later. The full Starship payload is designed to include 5 subgram digital cameras, each with at least 2 megapixels, 4 subgram processors, and 4 subgram photon thrusters, each performing at roughly the output of a 1-watt diode laser. Power would be provided by a 150 milligram atomic battery, possibly fueled by plutonium-238 or americium-241. A beryllium copper coating could shield the craft from atomic particle erosion and dust impacts. The light sail, likely a composite graphene-based material, must reflect most of the incident laser energy to avoid vaporization, and may even serve as a generator during cruise, producing up to 60 watts per square meter from collisions with the interstellar medium. Communication with Earth would use a laser system that reflects off the sail, potentially achieving 2.6 to 15 baud per watt of transmitted power at Alpha Centauri distances, assuming a 30-meter receiving telescope on Earth. While the baseline mission is a flyby, researchers such as René Heller have proposed using photogravitational assists, manipulating photon pressure for braking, to allow orbital insertion, though this would require a much larger and lighter sail. German physicist Claudius Groh has proposed a different application for starshot-derived technology, delivering microbial biospheres to transiently habitable exoplanets in a Genesis mission. Traveling at 4.6% of the speed of light, the probe could reach Alpha Centauri A in about 90 years, then use stellar photon pressure and a magnetic sail to successively brake toward Alpha Centauri B and finally Proxima Centauri, arriving roughly 140 years after launch. In 2025, researchers from Brown University and TU Delft unveiled a new AI-optimized light sail only 200 nanometers thick, patterned with billions of nanoscale holes. This structure reduced weight and increased reflectivity, significantly improving the efficiency of light-driven propulsion. Such advances could one day enable interstellar missions to nearby stars within a single human lifetime, turning Starshot's ambitious vision into a feasible reality. SpaceX has done it again. For years, the F-22 Raptor ruled the skies, but a new powerhouse has arrived. The X-59 flies faster than sound without the explosive sonic boom. Unlike older jets, it moves with stealth and speed, making it a true breakthrough in supersonic flight. With new technology, SpaceX is taking air travel to the next level, leaving countries like Hamas and China behind. What makes this aircraft different? Could it truly replace the legendary F-22 Raptor? Join us as we reveal the mind-blowing features of SpaceX's X-59 supersonic aircraft that is set to replace the F-22 Raptor. For decades, supersonic travel was a dream that came with one big problem, and that is the sonic boom. Every time an aircraft flew faster than sound, it always created a loud explosion that could be heard for miles. This led to strict regulations banning supersonic flights over land. Engineers wanted to solve this issue, but it was not easy to fix. The idea of quiet supersonic travel started in the 1960s, but the technology was not ready. Engineers knew that shaping the aircraft in a different way could reduce the boom, but they did not have the advanced materials needed to make it work. A lot of attempts were made, but the results were not what they wanted. The Concorde is one of the world's most famous supersonic passenger planes that flew at incredible speeds, but its loud boom and high fuel consumption led to its downfall. By 2003, the Concorde was retired, and supersonic travel was forgotten. But NASA was not ready to give up because their aim was to change the way supersonic planes were designed, and they had a plan. Instead of building a commercial aircraft, they decided to focus on an experimental aircraft that could test new technology. This was how the X-59 project began. In 2016, NASA awarded a contract to Lockheed Martin's Skunk Works, a team that is known for creating some of the most advanced aircraft in history. Their mission was simple, and that was to build a plane that could fly at supersonic speeds without the boom. They named it the X-59 QuiSST, which means Quiet Supersonic Technology. Skunk Works engineers had to take their time to make plans. They studied how shock waves traveled around an aircraft and used computer models to find the best shape. They discovered that by designing a long, slender body with a specially shaped nose, they could prevent shock waves from merging into a single loud boom. Instead, the waves would be spread out, creating only a soft thump that people on the ground would barely notice. The first major design review happened in 2017. NASA and Lockheed Martin tested small-scale models in wind tunnels to see how the aircraft would behave. These tests helped improve the shape and confirmed that their plan could work. In 2018, NASA officially gave Lockheed Martin the permission to start building the full-scale aircraft. In 2019, the pieces of the X-59 started coming together. The plane was designed to be 99 feet long, with a narrow fuselage and carefully placed wings. Unlike older aircraft, the cockpit was pushed far back, and there was no window facing the front direction. Instead, the pilots would rely on an advanced camera system for visibility. Originally, NASA expected the supersonic aircraft to fly by 2020, but there were delays in construction, testing, and funding that pushed the first flight further. Despite these setbacks, the team did not give up. In 2023, Lockheed Martin released footage of the X-59 rolling out of the hangar, showing the world that the aircraft was almost ready. They confirmed that the X-59 would soon begin test flights. The goal was to fly over selected cities and collect data on how people react to the new, quieter, supersonic sound. If successful, This research could change aviation forever, leading to new commercial aircraft that can fly faster than sound without disturbing people on the ground. One of the most amazing features of this aircraft is its nose. It is longer and more pointed than any other jet, stretching over a third of the plane's total length. This design helps the plane to spread out the pressure waves, stopping them from combining into a loud explosion. Instead of a regular windshield, the aircraft uses an advanced camera system. The external vision system includes a 4K camera that sends a live image to a clear display inside the cockpit. This gives the pilot a better view. It also has special sensors that help detect obstacles and improve visibility in bad weather. The wings of this jet are also different from those of other supersonic planes. They are placed at the back of the aircraft and are thinner than normal. This helps reduce drag and keeps the jet stable at high speeds. The tail of the aircraft is also split into two vertical stabilizers, which help control the movement of the plane and keep it steady in the air. The engine is another important part of the design. The X-59 is powered by a General Electric F-14 engine, the same type used in F-18 fighter jets. This powerful engine allows the aircraft to fly at speeds over Mach 1 without afterburners, making it more efficient and reducing noise. Unlike other supersonic jets, this supersonic jet has its engine intake on top of the fuselage instead of underneath. This helps block engine noise from reaching the ground, making the aircraft even quieter. The landing gear is not custom-made but borrowed from other planes. The front landing gear comes from an F-16, while the rear landing gear is taken from a T-38 trainer jet. This helps save money and speed up production since NASA did not have to develop new landing gear from scratch. Inside the aircraft, the cockpit is designed to be easy to use. The pilot has a modern glass display with digital controls instead of old dials and switches. However, the aircraft's quiet supersonic technology did not only reduce noise, but it also helped with fuel efficiency. Traditional supersonic jets burn a lot of fuel because of the extra drag created by shock waves. But since the X-59 minimizes these shock waves, it can travel faster while using less fuel. This makes it easier for long-distance travel and could help bring back commercial supersonic flights in the future. NASA and Lockheed Martin have also worked hard to make sure the aircraft is safe. Since it is an experimental jet, they have installed multiple backup systems in case something goes wrong. The aircraft is equipped with an automatic flight control system that helps the pilot manage stability at high speeds. It also has emergency landing procedures that allow it to glide safely in case of engine failure. While this jet is not built for combat, its technology has influenced the next generation of fighter jets. If supersonic planes can fly without creating loud booms, military jets can move faster than ever before. One of the biggest reasons this supersonic aircraft is so important is its potential to change aviation rules. The X-59 was built to change the future of supersonic travel, but it was not easy. From the start, engineers had to deal with major obstacles that threatened to slow down and even stop the project. Creating a supersonic plane that does not make a loud boom is not simple. Every part of the aircraft had to be carefully designed, tested, and adjusted. Even with advanced technology, problems kept coming up, forcing NASA and Lockheed Martin to find new solutions. One of the biggest challenges was making sure the aircraft actually reduced the sonic boom. The entire purpose of this aircraft is to prove that supersonic jets can be quiet, but this had never been done before. Engineers had theories, but until the plane was built and tested in real-world conditions, they could not be sure it would work. If the plane failed to reduce the boom, the entire project would be at risk. The long, pointed nose of this plane plays a huge role in controlling sound waves, but it also created a major issue. There was no room for a regular cockpit window, and this meant that the pilots could not see what was in front of them. Another issue was the balance and stability of the aircraft. The unique design of the plane, with its nose and thin wings, meant it had to be perfectly balanced to fly smoothly. Any miscalculation could make it hard to control, especially at high speeds. Engineers ran countless wind tunnel tests and computer simulations, adjusting the wing placement and tail design to make sure the plane would stay stable in flight. The engine placement also created issues. Most jets have their engine intakes on the bottom, but the X-59 has its intake on top to reduce noise. This change affected how air flowed into the engine, making it harder to keep the right amount of power during flight. Engineers had to adjust the design to make sure the engine could have enough air without causing issues that could affect performance. Building the aircraft itself was another challenge. Since it was an experimental aircraft, it was not built like a normal passenger or military jet. Many of its parts had to be custom-made, which took extra time and money. To save costs, the engineers used landing gear from other aircraft, but other components, like the unique nose structure and the cockpit system, had to be built from scratch. There were also delays in production. Designing and testing the aircraft took longer than expected, and some parts were harder to manufacture than planned. Supply chain issues also slowed down production, forcing the engineers to adjust their schedules. One of the biggest concerns was whether the government would actually allow supersonic planes to fly over land. There are strict rules that ban these flights because of the noise they create. The entire purpose of the X-59 is to prove that these rules can be changed, but that decision is not up to NASA. Even if the aircraft works perfectly, governments around the world need to agree that it is quiet enough to allow supersonic travel again. To help convince the governments, NASA has decided to test flights over several cities. These flights will allow people to hear the difference between a regular sonic boom and the quieter sound of the X-59. They will collect feedback from the public and use the data to argue that supersonic flights should be allowed, but there is no guarantee that the tests will be enough to change the laws. Another problem is the cost of future supersonic aircraft. If the technology is successful, it could lead to commercial planes that fly faster than sound. However, building and operating these planes will not be cheap. Airlines will need to decide if they are willing to invest in supersonic travel, and passengers will need to be willing to pay higher ticket prices. If airlines decide that it is not profitable, supersonic travel would not be allowed, even if the technology works. Also, supersonic jets use more fuel than regular airplanes, and fuel costs are a major concern for airlines. Even if this aircraft proves that quiet supersonic travel is possible, engineers will still need to find ways to make future aircraft more fuel efficient. Otherwise, the cost of flying these planes might be too high to make them practical for everyday travel. Another challenge is safety. Since this supersonic plane is a completely new type of aircraft, there is no long history of data to prove how safe it is. While the experts have run countless tests, the real proof will come when the aircraft flies regularly. Any issues that come up during test flights will need to be fixed before supersonic travel can become common. Despite these challenges, the engineers have worked for years to solve problems that once looked impossible. While there are still obstacles to overcome, each test brings them closer to making quiet, supersonic travel a reality. The X-59 is designed to change the future of supersonic travel, but supersonic speed has always been an important part of military air power. The United States Air Force has relied on speed and stealth to dominate the skies for decades. One aircraft that stands out as one of the most advanced fighter jets is the F-22 Raptor, which is set to be replaced by the X-59. This fighter was created to be the ultimate air superiority jet, and it is one of the most feared aircraft in the world. In the 1980s, the United States needed a new jet to replace the older F-15 Eagle and F-16 Fighting Falcon. These aircraft were strong, but military experts knew that future enemies would have better weapons and more advanced fighter jets. The country needed a new fighter that could defeat any threat in the sky. The United States Air Force started the Advanced Tactical Fighter program, which led to the development of two new aircraft. Lockheed Martin built one design, and Northrop Grumman built another. After years of testing, Lockheed Martin's design won, and the aircraft was officially named the F-22 Raptor. This fighter was built with one purpose, and that is to dominate air combat. It was faster, stealthier, and more advanced than anything that came before it. The first aircraft of its kind was introduced in the year 2005, and it quickly became the most powerful fighter in the world. While the Cold War had ended by the time the aircraft entered service, new threats were beginning to rise. Countries like China and Russia were developing their own advanced fighter jets, and the United States wanted to stay ahead. The F-22 became an important part of the United States Air Force's strategy to keep air superiority. One of the biggest advantages of this jet is its stealth. Enemy radars work by bouncing signals off aircraft, but this plane was built to be almost invisible. Its body is covered in radar-absorbent material, and its shape is designed to scatter radar waves in different directions. Even when enemy radars pick up a signal, it appears as something much smaller, just like the size of a bird. This makes it incredibly hard to track and even harder to lock onto with missiles. Also, this jet could fly faster than the speed of sound without using afterburners. This is called supercruise, and it allows the fighter to cover long distances quickly while saving fuel. Older jets had to use afterburners to go supersonic, which burned fuel fast and made them easier to detect, but it was not a problem for the Raptor. Maneuverability is where the Raptor truly shines. It uses thrust vectoring nozzles, which allow the engines to change direction mid-flight. This means the jet can turn, climb, and twist in ways that other planes cannot. In battles, this gives the pilot an advantage, allowing them to get behind an enemy and fire before they even see what is coming. This aircraft is also loaded with powerful weapons. It carries 6 AIM-120 AMRAAM missiles and 2 AIM-9 Sidewinder missiles for air combat. These missiles can lock onto targets from miles away, striking before the enemy knows what hit them. The jet also has a 20mm Vulcan cannon with nearly 500 rounds, giving it firepower for close-range combat. Aside from that, it can carry 2 1,000-pound GPS-guided bombs, allowing it to take out targets while staying undetected. The cockpit is designed to give the pilot complete awareness of their surroundings. It has 6 color displays that show real-time data on threats, targets, and mission status. A special helmet-mounted display allows the pilot to aim weapons just by looking at a target. This means the Raptor can fire at enemies without even needing to point the nose of the plane at them. The jet's advanced radar system can track multiple targets at once, even from extreme distances. It can detect enemy aircraft long before they come close, allowing the pilot to fire and stay out of harm's way. This radar is also built to resist enemy jamming, making it harder to block or interfere with. It can also gather intelligence. Its sensors can detect enemy movements and share information with other aircraft in real time. This makes it a key part of any mission, helping commanders make better decisions based on the latest data. But as powerful as the F-22 is, it has faced a lot of problems. One of the biggest challenges is its price. This jet was extremely expensive to develop and build. Each jet costs a lot of money, and maintaining them is just as costly. Another issue is that the aircraft has never been exported. Unlike the F-35, which is sold to many allied nations, the Raptor is only used by the United States. This means there is no extra funding from other countries to help with upgrades and maintenance. The entire cost of keeping the jet operational falls on the United States Air Force. Technology has also moved forward since the Raptor was first introduced. While it is still one of the best fighter jets, modern aircraft are being developed with even more advanced systems. Even training pilots for the jet has been a challenge. Since there are so few of these jets, pilots have limited opportunities to practice in them. The Air Force has used flight simulators to help with training, but nothing replaces real flight experience. If the government ever needed to send large numbers of Raptors into combat, there might not be enough trained pilots to fly them. Another problem is that the plane was built mainly for air superiority. While it can strike ground targets, it was not designed for bombing missions like the F-35. The Air Force has tried to upgrade the Raptor to handle more missions. But because production ended early, some improvements have been harder to make. Despite these challenges, this aircraft remains a crucial part of the United States military. The development of the F-22 Raptor and the X-59 shows how much aviation technology has changed over the years. Elon Musk's latest revelation has left military experts shocked as he turns impossible dreams into reality. A hypersonic marvel that could make America's enemies obsolete overnight. The extraordinary Starjet, shrouded in mystery until now, promises to shatter every limitation of modern aviation and make flying from New York to Beijing in less time than your morning coffee break impossible. Could this supersonic titan end traditional warfare as we know it? And what happens when this technology falls into the wrong hands? Join us as we find out all about Elon Musk's new supersonic space jet. While most planes still crawl through the sky at traditional speeds, Elon Musk's Starjet is about to change everything we know about air travel. This revolutionary aircraft doesn't just promise faster flights, It aims to turn day-long journeys into quick trips shorter than your average lunch break. The Starjet stands out from regular planes in several key ways. Unlike traditional aircraft that need long runways, this innovative vessel can take off like a rocket. Once airborne, it soars to the edge of space, where the thin air allows it to reach mind-boggling speeds of Mach 5, about 3,800 miles per hour. To put this in perspective, today's fastest commercial planes typically cruise around 550 miles per hour. At the heart of Starjet's breakthrough performance is its advanced Raptor engine. These powerful engines run on liquid methane and oxygen, a cleaner and more efficient fuel combination than traditional jet fuel. The methane provides tremendous thrust and helps cool the engine during high-speed flight, solving one of the biggest challenges in supersonic travel: extreme heat. The Starjet's body is a masterpiece of engineering. Its pointed nose and large triangular wings aren't just for show. They're carefully designed to cut through air resistance at incredible speeds. The entire aircraft uses unique materials like carbon fiber and heat-resistant metals that can withstand hot temperatures to melt standard airplane parts. One of the most remarkable features is its dual-mode propulsion system. During takeoff and initial flight, the Starjet uses traditional jet engines. But when it's time to move, it switches to its rocket engines, allowing it to climb to altitudes where regular planes can't operate. At these heights, between 150,000 to 200,000 feet above Earth, the thin atmosphere creates less drag, enabling those record-breaking speeds. The engineering team faced unique challenges when designing Starjet's skin. At Mach 5, the friction from air molecules creates enough heat to cook a steak in seconds. To handle this, they developed a unique thermal protection system similar to those used on space shuttles but redesigned for repeated use. Safety features include advanced navigation systems that automatically adjust the flight path thousands of times per second, ensuring stable flight even at extreme speeds. Multiple backup systems and fail-safes are built in, making the Starjet potentially safer than conventional aircraft. While the Starjet's incredible engineering feats push the boundaries of what's possible in the sky, the real question that has everyone buzzing is, what's it like to fly in this revolutionary aircraft? And can it keep passengers comfortable while zooming through the atmosphere at 5 times the speed of sound? Inside the Starjet, comfort meets cutting-edge technology in ways never seen before in aviation. The cabin is designed to make passengers feel at home, even while flying at the edge of space. Unlike regular planes where turbulence shakes everyone aboard, the Starjet uses advanced stability systems that smooth the ride, much like sailing on calm waters. The cabin's pressure control system is a marvel of modern engineering. While regular planes fly at around 35,000 feet, the Starjet cruises at heights where the air is too thin to breathe. Special sensors constantly monitor and adjust cabin pressure, keeping it at natural levels to passengers. The air inside is continuously filtered and refreshed, making it cleaner than what you'd breathe in most buildings. Each seat has personal climate controls and noise-canceling technology built into the headrest. This helps counter the subtle vibrations and sounds of hypersonic flight. The windows are high-definition screens connected to external cameras, giving passengers crystal-clear views without compromising the aircraft's structural integrity. But the Starjet isn't just about passenger comfort. It's also designed with our planet in mind. Its methane fuel produces significantly less carbon dioxide than traditional jet fuel. When burned with liquid oxygen, it creates mainly water vapor and carbon dioxide, with almost no harmful particles that regular jets pump into the atmosphere. The aircraft's flight path is carefully planned to minimize its environmental impact. By flying at extremely high altitudes, it avoids disturbing wildlife and creates less noise pollution than current planes. The sonic booms it produces happen so high up that they dissipate before reaching the ground, solving a problem that plagued earlier supersonic aircraft like the Concorde. Even the materials used in Starjet's construction are chosen with sustainability in mind. Many parts are designed to be easily recycled or reused, and the manufacturing process uses less energy than traditional aircraft production. The special coating that protects the plane from extreme heat is made from natural minerals, reducing the need for synthetic materials. The entertainment system is equally impressive. It features augmented reality displays that let passengers track their flight path, view points of interest from above, or even see what constellations they're flying past. Built-in screens can switch between entertainment and transparent modes, letting passengers choose between watching movies or gazing at the curve of the earth below. Medical monitoring systems are discreetly built into each seat, keeping track of passengers' well-being during the flight. If someone starts feeling unwell, the system alerts the crew immediately. A small medical bay is equipped with emergency equipment, ensuring passenger safety even at the edge of space. These features show that the Starjet isn't just about breaking speed records. It's about making ultra-fast travel comfortable, safe, and environmentally responsible. But how will this revolutionary aircraft reshape our world? And what does it mean for the future of global business, tourism, and everyday travel? The Starjet isn't just another new airplane. It's set to transform how we think about distance and time in our modern world. The possibilities become endless when a flight from New York to Shanghai takes less time than a daily commute. Business meetings that once required week-long trips could happen over lunch. Fresh produce from South America could reach European markets in minutes instead of days. For businesses, this change could spark a new era of global operations. Companies could maintain offices across different continents, with teams quickly moving between locations. Time zones would become less of a barrier when executives can attend morning meetings in Tokyo and afternoon sessions in London on the same day. The tourism industry stands to change dramatically too. Weekend trips to destinations halfway across the world would become practical. A family could have breakfast in Chicago, spend the afternoon exploring the Great Wall of China, and be home for dinner. This could lead to new types of travel packages and adventures that weren't possible before. The cargo and shipping industry would see massive changes. High-value, time-sensitive items like medical supplies, donated organs, or critical machine parts could reach anywhere on Earth within an hour. This speed could save lives and reduce costly delays in global supply chains. Scientists and researchers would benefit from faster transport of sensitive materials. Samples that need quick analysis, experimental medicines, or critical research materials could move between labs worldwide without losing precious time. This could speed up scientific discoveries and medical breakthroughs. The Starjet's technology is also pushing the boundaries of what's possible in aircraft design. Engineers are already working on plans for even faster planes, aiming for Mach 10 speeds, which is about 7,600 miles per hour. These future aircraft might use new types of engines and materials that don't even exist yet. Emergency response teams could reach disaster areas faster than ever before. Relief supplies and medical teams could arrive within hours of a crisis, potentially saving many more lives during natural disasters or humanitarian emergencies. But these changes won't happen overnight. The first Starjets will likely serve specific routes between major cities. As more are built and the technology improves, the network of hypersonic flights will grow. Airports will need new facilities to handle these advanced aircraft, and air traffic systems will need updates to manage these ultra-fast flights. The cost of tickets will start high, similar to how early airplane travel was only for the wealthy. But as more Starjets enter service and the technology becomes more common, prices should gradually come down, making this super-fast travel available to more people. Looking even further ahead, Starjet's technology could help develop new kinds of space travel. The lessons learned from flying at the edge of space might help engineers design better spacecraft for trips to the Moon, Mars, and beyond. As revolutionary as the Starjet's impact on civilian travel promises to be, there's another arena where this technology could be even more game-changing. What happens when this incredible speed meets military might? And how could it reshape the balance of power in our modern world? The military version of hypersonic flight is already taking shape through Hermes Corporation's groundbreaking work with the United States Air Force. Their quarter-horse Mk-1 aircraft represents a leap forward in military aviation that goes far beyond anything currently flying. At speeds over Mach 5, this aircraft could respond to threats anywhere on Earth within minutes, dramatically changing how nations think about defense and security. Unlike its commercial cousin, the quarter-horse Mk-1 is built for stealth and combat capability. Its special coating absorbs radar signals, making it nearly invisible to enemy detection systems. The aircraft's frame is reinforced to handle extreme maneuvers at hypersonic speeds, something that would tear apart conventional fighters. The United States military's interest in this technology stems from a pressing need. Current fighter jets, even the most advanced ones, are becoming vulnerable to new defense systems. Russia and China have developed missiles that can track and potentially intercept traditional aircraft. A hypersonic jet could simply outrun these threats, flying too fast for existing defense systems to react. The Air Force plans to use these aircraft for various missions. They could quickly deliver special forces teams to crisis points, conduct rapid reconnaissance of hostile areas, or transport critical military cargo across vast distances. The ability to reach any point on Earth within an hour completely changes military planning. But it's not just about combat. The military version includes sophisticated sensors and cameras that can scan vast areas in minutes, helping track environmental disasters, monitor border security, or assist in search and rescue operations. These capabilities make it valuable for humanitarian missions as well. One of the most interesting developments is the unmanned version called Dark Horse. This robotic aircraft can perform dangerous missions without risking pilot lives. It can fly into storms, through volcanic ash, or near radiation-contaminated areas to gather critical data. The Dark Horse can stay in the air longer than piloted aircraft and perform more extreme maneuvers since it doesn't need to account for human limitations. The government has also shown interest in using this technology for presidential travel. A hypersonic Air Force One could quickly evacuate leaders during emergencies or allow the president to respond personally to international crises within hours. The current presidential aircraft would take nearly a day to reach some parts of the world. Training pilots for these new aircraft presents unique challenges. The speeds involved leave no room for error, and decisions must be made in split seconds. The Air Force is developing new simulation systems to prepare pilots for the extreme conditions they'll face at hypersonic speeds. This military development has sparked a new kind of space race. Other countries are rushing to develop their hypersonic aircraft, leading to increased competition in aerospace technology. The nation that masters this technology first could gain a significant strategic advantage. The implications of these military applications extend beyond national defense. The technologies developed for military hypersonic flight often find their way into civilian use, just as GPS and the internet did. While military applications of hypersonic flight push the boundaries of what's possible, an even more intriguing revolution is brewing in the commercial sector. How are private companies racing to bring this incredible technology to everyday travelers? And which innovative approaches might win the race to dominate our future skies? The commercial aviation world is buzzing with activity as companies compete to develop the next generation of super-fast passenger planes. Leading this charge is Boom Supersonic, with its ambitious Overture aircraft. Unlike military planes focused on stealth and combat, these commercial jets prioritize passenger comfort while still achieving remarkable speeds. Boom's smaller test plane, nicknamed Baby Boom, serves as a proving ground for new technologies. This aircraft, about the size of a small business jet, helps engineers solve tricky problems like reducing sonic booms and managing extreme heat before building the full-size passenger version. Each test flight provides valuable data that shapes the future of commercial supersonic travel. NASA has joined the race with its X-59 program, taking a unique approach to solving one of supersonic flight's biggest problems: the loud sonic boom that disturbs people on the ground. Their aircraft uses a specially shaped nose and body to spread out the shock waves that cause sonic booms, turning them into soft thumps barely louder than a car door closing. Different companies are exploring various innovative designs. Spike Aerospace has created a windowless passenger cabin, replacing traditional windows with large display screens showing HD video from external cameras. This design makes the plane stronger and faster while giving passengers an even better view than regular windows. The competition has sparked creative solutions to old problems. Some companies are developing new types of engines that work efficiently at both low and high speeds. Others are experimenting with sustainable fuels to make super-fast travel environmentally friendly. These advances benefit the entire aviation industry, even planes that don't fly at supersonic speeds. Airlines are watching these developments closely. United Airlines has already placed orders for several Boom Overture aircraft, betting that passengers will pay extra for drastically shorter flight times. Other airlines are waiting to see how the technology develops before making commitments. Cost remains a significant challenge. Building these advanced aircraft requires expensive materials and complex manufacturing processes. Companies are working to find ways to make the planes more affordable without sacrificing safety or performance. Some are using new manufacturing techniques like 3D printing to reduce costs and speed up production. Weather protection is another focus area. These fast planes need unique systems to detect and avoid storms, as even tiny raindrops can damage aircraft moving at such high speeds. Engineers are developing advanced radar systems that can spot dangerous weather patterns from hundreds of miles away. Airports are preparing for this new era too. They're planning special terminals for supersonic flights and training ground crews to handle these advanced aircraft. Some airports are even designing new runways specifically for these faster planes. As these various approaches compete to become the future standard of air travel, each company brings unique solutions to everyday challenges, pushing the boundaries of what's possible in commercial aviation. While today's companies race to perfect supersonic passenger travel, the shadow of aviation history looms large over their efforts. What crucial lessons can we learn from the past triumphs and failures? And will these new ventures finally succeed where others have fallen short? The story of supersonic passenger travel begins in the 1950s, when the boom of jet engines changed aviation forever. The most famous success story was the Concorde, born from an unlikely partnership between Britain and France. This sleek aircraft could zoom across the Atlantic Ocean in just 3 hours, less than half the time of regular planes. The Concorde was an engineering marvel that seemed to defy the laws of physics. As it flew, its surface heated up so much that the entire plane stretched, growing longer by 7 inches during flight. Its pointy nose could tilt down during takeoff and landing to help pilots see the runway better, then lift during flight to cut through the air faster. But even this fantastic plane faced immense problems. The loud sonic booms it created led many countries to ban supersonic flights over land. This meant the Concorde could only fly over oceans, limiting its routes and making it hard for airlines to make money. Then fuel prices shot up in the 1970s, making each flight extremely expensive. Only 14 Concordes ever carried paying passengers, far fewer than planned. Tickets were so expensive that only the very wealthy could afford to fly on them. While regular planes like the Boeing 747 carried hundreds of passengers efficiently, the Concorde struggled to fill its small cabin of just 100 seats. The final blow came on July 25, 2000, when a tragic accident in Paris ended the Concorde's reputation for safety. A small piece of metal on the runway punctured a tire, sending rubber pieces flying into the fuel tank. The resulting crash changed how people viewed supersonic travel, and by 2003, all Concordes were retired. The future of supersonic flight faces other hurdles as well. New planes must meet strict environmental rules that didn't exist in the Concorde's day. They need to be quieter, cleaner, and more fuel efficient than ever before. Engineers are working on engines that pollute less and testing sustainable plant-based fuels. Government agencies like the FAA are creating new rules for these fast planes, learning from past experiences to ensure their safety. They're also working with companies to test new technologies and ensure that sonic booms won't bother people on the ground. Despite these challenges, the dream of fast air travel lives on. With better technology, smarter designs, and lessons learned from history, today's aviation pioneers might finally succeed in making supersonic flight a regular part of air travel, not just a luxury for the few. Elon Musk's SpaceX has consistently pushed the boundaries of aerospace technology, but their recent revelation, a UFO-like aircraft, has captivated imaginations in ways never seen before. Operating at unprecedented speeds and utilizing groundbreaking propulsion methods, this craft challenges everything we know about flight and physics. Beyond just an aviation marvel, this UFO aircraft may hold the key to reshaping space travel, military defense, and even the way humanity views extraterrestrial life. How did SpaceX, a company known for its reusable rockets, make such a leap? And what could this mean for the future of exploration and technology? SpaceX's UFO aircraft, recently revealed by Elon Musk, has ignited curiosity and excitement due to its groundbreaking technology and physics-defying capabilities. This craft, unlike any traditional aircraft, is designed to operate at extraordinary speeds with unmatched maneuverability, challenging current aviation standards. The first standout feature of this UFO aircraft is its unparalleled speed. Musk's team claims it can travel faster than any existing human-made vehicle, surpassing the SR-71 Blackbird, which holds the record for the fastest jet at 2,193 miles per hour. Sources within SpaceX indicate the UFO aircraft can potentially reach speeds far beyond Mach 10, though exact figures remain classified. This level of speed sets the stage for its second incredible feature, maneuverability. In contrast to conventional aircraft, which rely on aerodynamic surfaces like wings and rudders for direction, the UFO aircraft can make sudden, sharp directional changes that would be impossible for standard vehicles. Avi Loeb, an astrophysicist studying the potential behind such crafts, has described similar UFOs as highly maneuverable, with abilities that seem to defy physics. He also points out that the propulsion system allows it to stop instantly or change direction without the need for traditional methods, such as air friction adjustments. What powers this craft? According to SpaceX insiders, the UFO aircraft operates using a propulsion system that breaks free from traditional fuel constraints. Instead of jet fuel or any other known sources, it likely harnesses energy from a revolutionary electromagnetic field propulsion system. Similar technology has been speculated on in government reports discussing unidentified aerial phenomena, UAP, where crafts appear to move without visible means of propulsion. Harvard researchers and Pentagon officials have hinted at propulsion systems using gravitational fields, allowing such vehicles to travel long distances without traditional engines or combustion, which require fuel. Elon Musk has alluded to similar systems, stating, "The technology we're experimenting with has the potential to change everything we know about flight. Such propulsion technology, if confirmed, could drastically reduce energy consumption while enabling interstellar or high-speed terrestrial travel." Another fascinating aspect of the UFO aircraft is its apparent defiance of known physics, particularly when it comes to friction and drag. As Loeb noted, sightings of similarly fast-moving UFOs have shown no signs of the typical optical fireball caused by friction when an object moves rapidly through the atmosphere. In theory, the UFO aircraft should generate heat and light from air resistance, but SpaceX engineers may have found a way to mitigate this, possibly through a frictionless exterior or some form of electromagnetic shielding. While details are scarce, Musk's cryptic hints about working with some of the world's top physicists suggest that previously classified technology may be at play. SpaceX might be using highly advanced materials, perhaps something akin to superconductors, that eliminate friction, allowing the craft to move seamlessly through air and even water. This aligns with previous UAP studies from the Pentagon, where UFOs have been seen traveling through both mediums with equal ease. Visually, the UFO aircraft differs significantly from both military and commercial aircraft. It's said to have a streamlined, disc-shaped design, minimizing drag and allowing for the efficient management of heat and pressure at high speeds. Compared to modern stealth fighters like the F-35, which rely on angular surfaces to reduce radar signatures, the UFO aircraft needs no such external designs. It can evade detection entirely, operating silently and without leaving traditional heat signatures that would be picked up by radar. Moreover, the aircraft's compact design allows it to perform functions that large, heavy planes cannot achieve. Its agility and ability to hover or even remain stationary make it ideal for a wide range of applications, including surveillance or possibly even military operations. This opens the door to questions about whether the technology behind this aircraft stems from government partnerships or collaborations with leading physicists. Musk's comments about previously classified technology certainly point in that direction. In comparison to SpaceX's other innovations, such as the Starship, which relies on methane-powered Raptor engines, the UFO aircraft represents a massive leap in technology. It pushes the boundaries of propulsion and aerodynamics, offering potential applications far beyond what SpaceX's current spacecraft can achieve. The Starship, designed for interplanetary travel, still relies on traditional fuels, while the UFO aircraft doesn't seem to share this limitation. But how exactly did SpaceX develop this groundbreaking technology? Was it a stroke of genius or the result of years of classified research? From the outset, Musk aimed to revolutionize space travel through innovation in propulsion systems and sustainable technology. SpaceX's Falcon rockets and Starship have demonstrated this ambition, successfully utilizing reusable rocket technology. A leap that reduced launch costs by 60%, a milestone for the aerospace industry. Falcon 9, first launched in 2010, pioneered reusable rockets, allowing the first stage to land back on Earth, a feat that had been unthinkable for traditional aerospace companies. This achievement set the stage for future technologies, creating the foundation for SpaceX's more experimental, groundbreaking projects, such as the UFO-like aircraft currently in development. The Falcon Heavy, launched in 2018, further pushed boundaries, using 3 reusable Falcon 9 cores and achieving unprecedented payload capacity, thus proving the viability of Musk's long-term vision for multiplanetary travel. Over the years, Musk has repeatedly teased advanced propulsion systems that could potentially redefine how we think about flight and space travel. In a 2021 interview, Musk mentioned, "There are certain propulsion technologies that are still in the conceptual phase, but if realized, could completely eliminate the need for chemical fuels." The notion of anti-gravity propulsion, while still unproven in mainstream science, is being explored in small pockets of aerospace research. The Breakthrough Propulsion Physics (BPP) project, led by NASA in the early 2000s, sought to explore the feasibility of faster-than-light travel and anti-gravity propulsion, although it was eventually discontinued due to budget constraints. However, Musk's SpaceX could be building on these early attempts, with sources close to the company indicating that research into advanced materials and energy fields is underway. SpaceX's experimental division is rumored to be collaborating with some of the world's leading physicists, including those from institutions like MIT and Caltech, in developing these revolutionary propulsion systems. Dr. Richard Feynman, a well-known figure in theoretical physics, had theorized the possibility of anti-gravity propulsion decades ago, and today's researchers are taking his ideas further. Musk's interest in pushing the boundaries of propulsion is further exemplified by SpaceX's ongoing efforts in space mining and resource harvesting, which align with the long-term goal of interstellar travel. His vision of a self-sustaining colony on Mars relies on new propulsion technologies, and this UFO aircraft could very well be the stepping stone to achieving that. The experimental research being done now could have major implications for human colonization of space and even deeper space exploration. So what are the larger implications of this technology? Could this be the key to unlocking human exploration of deep space? Or are we witnessing the dawn of entirely new applications for Earthbound travel? At present, it takes around 6-9 months to reach Mars using conventional technology. NASA's Perseverance rover, launched in July 2020, took approximately 7 months to travel 300 million miles to the Red Planet. With SpaceX's revolutionary technology, the potential to cut this travel time significantly is immense. If the UFO aircraft can reach speeds far beyond current limitations, missions to Mars could be completed in weeks instead of months, transforming the feasibility of human colonization on the planet. Scientists currently speculate that even reaching the outer planets of our solar system takes several years. For example, the New Horizons spacecraft, launched in 2006, took nearly a decade to reach Pluto. If SpaceX's UFO aircraft can overcome the barriers of speed and distance, exploring distant planets or even neighboring star systems could become achievable within a human lifetime. Furthermore, breakthroughs in electromagnetic propulsion could lead to faster-than-light travel. This concept, long a staple of science fiction, is theoretically possible through what's called a warp drive, where space-time itself is manipulated to allow for superluminal speeds. Research in this area has been slow, but prominent physicists such as Dr. Miguel Alcubierre have proposed mathematical models showing how such technology could function. When asked about the future of space travel, Musk once remarked, "What if we could travel to Mars in just a few weeks? Or to Alpha Centauri in our lifetime?" These aren't crazy ideas, they're future possibilities. This vision aligns perfectly with the potential of SpaceX's UFO aircraft, which could bypass the limitations of current propulsion systems and enable humanity to venture deeper into space. Another significant implication is the cost of space exploration. At present, launching a payload into orbit using the Falcon 9 costs approximately $62 million per launch. This figure is already a drastic reduction compared to NASA's previous methods. But if SpaceX's UFO aircraft can further reduce the cost by eliminating fuel requirements, It could lower the cost of space exploration by an order of magnitude. This would make it possible for smaller companies, research institutions, and even nations with smaller budgets to launch missions to space, democratizing access to the cosmos. The development of this craft could also expand our ability to conduct long-term space exploration. By eliminating the need for fuel and utilizing electromagnetic propulsion, spacecraft could operate for much longer durations without needing resupply missions. This would make it easier to establish permanent outposts on Mars or the Moon, or even construct space stations in orbit around other planets. Musk's long-term goal of creating a self-sustaining colony on Mars may no longer seem so far-fetched with this technology in hand. So with all these advancements in space travel, what about the military applications of this revolutionary craft? Could this technology change the nature of warfare as we know it? As governments and military organizations race to develop advanced aerospace technology, the UFO-like aircraft revealed by SpaceX presents game-changing potential. Its speed, maneuverability, and defense capabilities open the door to numerous military applications. For instance, its ability to make sudden directional changes and evade detection could revolutionize surveillance and intelligence missions. It could also serve as a platform for defense against extraterrestrial threats, a topic Elon Musk has occasionally hinted at in interviews. He has expressed concerns about Earth's defense readiness, stating, "There may be other civilizations that aren't friendly." Moreover, this UFO aircraft's unique propulsion system, based on electromagnetic fields or potential anti-gravity technology, could make it ideal for offensive purposes. Its high speed and ability to travel undetected could be used to deploy advanced weaponry or conduct precise military strikes without being intercepted. The lack of conventional fuel requirements would further enhance its endurance, allowing it to stay operational for extended periods during missions. Comparatively, current stealth fighters like the F-35 are constrained by fuel limitations, whereas this aircraft could operate continuously without needing to refuel, giving it a significant tactical advantage. The U.S. Department of Defense has already demonstrated an interest in advanced aerospace technologies. Programs like the U.S. Navy's AATIP, Advanced Aerospace Threat Identification Program, have focused on studying unidentified aerial phenomena, UAPs, many of which exhibit similar traits to SpaceX's UFO aircraft. The Pentagon has admitted to tracking objects that appear to defy known physics, and these objects could serve as templates for next-generation military aircraft. Musk has hinted that SpaceX may collaborate with military organizations on future projects. Given the secrecy around military defense projects, it's plausible that SpaceX's UFO technology could be integrated into defense strategies in the coming years. One of the most compelling military applications of this technology could be its use in planetary defense. While discussions of extraterrestrial threats might sound far-fetched, scientists and military officials are increasingly exploring the possibility. In fact, NASA's Planetary Defense Coordination Office, PDCO, is actively developing strategies to protect Earth from potential asteroid impacts or alien encounters. Musk has long spoken about humanity's vulnerability, not just from asteroids, but also potential alien civilizations. SpaceX's advancements could be used to create a rapid response defense system capable of intercepting threats from space or responding to global crises. Beyond Earth's defense, the UFO aircraft's military applications could also extend to space warfare. As nations like the US, China, and Russia invest heavily in space-based weaponry, the competition for space superiority is heating up. In 2019, the US Space Force was established to protect American interests in space. The UFO aircraft's ability to move at high speeds through space, avoid detection, and operate without fuel could give any nation deploying it a significant strategic advantage in space warfare. As more conflicts move beyond Earth's atmosphere, the importance of this kind of technology will only grow. But with technology this advanced, conspiracies and questions about its true origins are sure to arise. Could there be more to this than meets the eye? Theories surrounding SpaceX's UFO-like aircraft often delve into government collaboration and secrecy. Speculation abounds that SpaceX has worked with DARPA or other military agencies to develop this advanced technology. DARPA has a long history of involvement in aerospace advancements, such as the Falcon Hypersonic Technology Vehicle 2, HTV-2, which could reach speeds over Mach 20. The similarities between HTB-2's capabilities and SpaceX's UFO craft have fueled theories that DARPA might be behind the technology. Elon Musk himself has been cryptic, once hinting at collaboration by mentioning, "Some technologies are so advanced that they are indistinguishable from magic, and we may have been working on such things." There are parallels to other secretive defense projects, such as Lockheed Martin's Skunk Works, known for creating advanced military aircraft like the SR-71 Blackbird and the F-117 Nighthawk. Skunk Works operates in highly classified environments, often in collaboration with government agencies, and some believe that SpaceX's craft could be a continuation of such secretive developments. The UFO aircraft's sudden directional shifts and unexplainable propulsion have led many to theorize that it might be part of a classified military initiative to keep this technology hidden. Public UFO sightings have only added fuel to the fire. In 2020, the U.S. Department of Defense released footage of tic-tac-shaped UFOs observed by U.S. Navy pilots. These crafts demonstrated rapid acceleration, sudden changes in direction, and a lack of visible propulsion, all characteristics consistent with the technology that SpaceX's UFO aircraft is reported to possess. Many experts, including Nick Pope, who worked on the British Ministry of Defence's UFO program, have speculated that SpaceX's cutting-edge technology could be responsible for many of these unexplained phenomena. Pope has stated, "If we're seeing technology that defies what we understand of physics, it's reasonable to assume someone, perhaps SpaceX, is behind it." Further theories suggest that SpaceX's craft might be tied to ongoing UAP, unidentified aerial phenomena, studies being conducted by government agencies. Since 2017, when the New York Times exposed the Pentagon's Advanced Aerospace Threat Identification Program, AATIP, there has been growing interest in understanding UAPs and their potential implications for national security. SpaceX's rapid advancements in propulsion technology and aerospace engineering have led some to wonder if they are contributing to these investigations. Speculation persists that SpaceX has been covertly testing their UFO-like aircraft, accounting for many of the mysterious sightings reported in recent years. On the flip side, Elon Musk has publicly dismissed the idea that extraterrestrial life is behind UFO sightings. Musk is well known for his belief in the potential for life beyond Earth. But when it comes to UFOs, he has repeatedly stated that he doesn't believe they are of alien origin. Instead, he attributes these sightings to advanced human-made technology, possibly even SpaceX's own. He once quipped on Twitter, "If there were aliens, trust me, I'd know," implying that whatever people are seeing in the skies could likely be attributed to secretive government or corporate projects, not extraterrestrial visitors. Despite Musk's denials of alien involvement, conspiracy theories still abound. Some argue that SpaceX is using alien technology to develop these aircraft, a notion that gained traction following the release of classified Pentagon documents detailing encounters with unexplained aerial phenomena. Skeptics point to Musk's rapid rise in aerospace technology and the seeming leap from conventional rockets to UFO-like propulsion as evidence that SpaceX has access to otherworldly technology. However, these claims remain unverified, with no direct evidence linking SpaceX to extraterrestrial sources. Another theory involves SpaceX's partnership with NASA. Since 2012, SpaceX has been working closely with NASA on various space missions, including the Commercial Crew Program. Some believe that this collaboration extends beyond traditional space exploration, with NASA secretly feeding SpaceX advanced technology originally developed for deep space missions. The theory posits that SpaceX's UFO aircraft could be a product of shared research with NASA's highly classified space exploration projects. This would explain Musk's ability to push the boundaries of aerospace technology so rapidly, as NASA has long been involved in the research and development of propulsion systems capable of interstellar travel. Yet another theory focuses on SpaceX's potential ties to secret military defense programs, particularly the Space Force. The U.S. Space Force was officially established in 2019, and it is dedicated to protecting American interests in space. Some conspiracy theorists suggest that SpaceX is working in tandem with the Space Force to develop spacecraft capable of defending Earth from extraterrestrial threats or other nations. Musk has spoken about the need to secure our future and has hinted at the potential military applications of SpaceX technology. This theory suggests that the UFO-like craft could be used as part of an advanced defense system designed to counter threats from beyond Earth. These theories continue to fuel controversy and intrigue, especially as Musk remains tight-lipped about the true capabilities of SpaceX's UFO aircraft. But with all these groundbreaking claims and speculative theories, not everyone is convinced. What do leading scientists say about the feasibility of this technology? Elon Musk's bold claims about SpaceX's UFO aircraft have drawn both admiration and skepticism. While enthusiasts hail it as the next step in aviation and space travel, many scientists remain cautious. Leading experts in aerospace engineering and physics, such as Harvard's Avi Loeb, have expressed concerns about the feasibility of some of these technologies, particularly electromagnetic propulsion and anti-gravity. Loeb, known for his work on the search for extraterrestrial intelligence, states that while the concept of an anti-gravity propulsion system sounds exciting, it contradicts current scientific understanding. The principle of electromagnetic propulsion, which suggests using magnetic fields to push objects forward without fuel, has fascinated researchers for decades. However, experts like David Spergel, a theoretical astrophysicist at Princeton, argue that despite significant advances in electromagnetism, creating propulsion systems that defy gravity and generate the power needed for interstellar travel remains speculative. Spergel points out that creating a functional propulsion system of this nature would require manipulating enormous amounts of energy, far beyond anything currently achievable. He explains, "For this kind of system to work, the energy requirements would be so immense that it's hard to see how we can bridge the gap between theory and reality." Even more controversial is the claim of achieving anti-gravity propulsion. The idea that a craft could float freely or move without interacting with gravity as we know it is viewed with skepticism in the scientific community. Aerospace engineers, including Richard M. Muller of UC Berkeley, note that although the concept of anti-gravity has been explored theoretically in the context of general relativity and quantum mechanics, no experimental evidence exists to suggest that anti-gravity propulsion is anywhere near becoming a practical reality. The scientific community has also questioned the idea that SpaceX's UFO-like craft could move at such high speeds without generating friction or heat, phenomena governed by the basic laws of physics. Heat generated from air resistance is one of the major obstacles for any high-speed vehicle, let alone one operating at the altitudes and velocities described. Most recently, aerospace engineer John D. Anderson Jr., an expert on aerodynamics, suggested that for the craft to move as described without creating visible heat signatures or sonic booms, a whole new understanding of materials science and heat dynamics would be necessary. He says, "The idea that an object could move that quickly through Earth's atmosphere without experiencing heat buildup would require a material we have yet to discover." Despite these criticisms, it's essential to remember Musk's track record of defying naysayers. From electric cars with Tesla to reusable rockets with SpaceX, Musk has continually proved that what seems impossible at first can often be achieved with persistence and innovation. When Tesla was founded, many industry insiders doubted that an electric car could compete with gasoline-powered cars, yet Tesla is now the most valuable car company in the world. Similarly, the idea of reusable rockets seemed far-fetched until SpaceX's Falcon 9 successfully landed after a space mission, significantly lowering the cost of space travel. Some experts also believe that Musk's claims might be grounded in technologies that are still in the experimental phase, but have the potential to disrupt the industry. For instance, researchers at NASA's EagleWorks laboratories have been investigating the M-Drive, a controversial form of propulsion that, if validated, could change space travel forever. Though the M-Drive hasn't been definitively proven, the mere exploration of such advanced technologies gives hope that SpaceX might be on the right track. So while scientists debate the feasibility of these ideas, one question remains. Could the future of aerospace engineering still hold surprises that will push the limits of our current understanding? Elon Musk and SpaceX have always been at the forefront of revolutionary technology, and the future of their UFO aircraft promises to be no different. This groundbreaking craft, which reportedly incorporates anti-gravity and electromagnetic propulsion systems, opens up several exciting possibilities for the future of aerospace and space exploration. As SpaceX pushes forward, key projects and innovations already in development could further advance this technology and transform how we view space travel. A significant development to keep an eye on is SpaceX's work with the U.S. military. In recent years, SpaceX has secured contracts with the Department of Defense to explore advanced rocket technologies for defense purposes. For example, Project Blackjack, a DARPA-led initiative, involves using SpaceX's Starlink satellite constellation for military communications and reconnaissance. While Project Blackjack focuses primarily on satellite technology, the interest from DARPA suggests that SpaceX's UFO aircraft could play a role in future military applications. Government contracts like these could provide the funding and testing environments necessary for SpaceX to refine its propulsion technologies and move closer to public demonstrations of the UFO aircraft. Moreover, SpaceX is actively involved in research and development around next-generation materials. One such initiative is their ongoing partnership with Tesla's Advanced Materials Lab, which explores lightweight, heat-resistant materials for both spacecraft and terrestrial vehicles. These materials could be critical for the development of frictionless surfaces that enable the UFO aircraft's high-speed movement through the atmosphere without generating the heat traditionally associated with high-speed travel. Speculation is rampant that SpaceX may commercialize this technology in much the same way they've done with space exploration. In 2020, SpaceX became the first private company to send astronauts to the International Space Station, a feat that had previously been the exclusive domain of government agencies like NASA. The potential for partnerships and collaborations also presents exciting opportunities for SpaceX. For example, the European Space Agency, ESA, and NASA have both shown interest in working with private companies to advance space technologies. Given the scope of the UFO aircraft's capabilities, it's not out of the question that SpaceX could partner with international agencies for future exploration missions, possibly contributing to the next manned mission to the Moon or even beyond to Mars. Such collaborations could be crucial for refining the technology and making it accessible on a global scale. As for the timeline, Musk has hinted that more official announcements regarding the UFO aircraft will be made soon. While specific dates are still unknown, it's likely that within the next few years, SpaceX will begin conducting public tests or unveiling more detailed information about the craft's capabilities. These tests will likely provide concrete data on how the UFO aircraft functions in real-world scenarios and how it could be applied to upcoming space missions or other aerospace endeavors. As SpaceX forges ahead with this revolutionary craft, the implications are enormous. Whether in space exploration, defense, or commercial applications, the future feels closer than ever. Yet with skepticism from scientists and secrecy from the government, much remains uncertain. One thing is clear, this UFO aircraft is just the beginning of an exciting new era in aerospace. Are you ready to witness the future unfold? Stay tuned for more as we uncover what's next from Musk and SpaceX. The skies, and perhaps the stars, are no longer the limit. The United States Air Force has always had their technological needs catered for by three of the biggest aerial combat vehicle manufacturers in the country: Northrop Grumman, Boeing, and Lockheed Martin. However, the advent of Elon Musk's SpaceX in 2002 birthed the rise of serious competition in the creation of aerial vehicles. Fast forward to 2025, and SpaceX has reportedly come up with an enticing new bomber plane for the United States Air Force. Could this be the future of bomber jets? Is there a chance that this new cutting-edge bomber sparks a global arms race? Join us as we discuss the brewing bomber between SpaceX and the United States Air Force. Although top high-tech companies like Lockheed Martin, whose Skunk division has played a major role in the creation of some of the United States' greatest combat aerial vehicles, and Northrop Grumman have been at the top end of the pile as the go-to for the America's Department of Defense, the sudden surge of Elon Musk and his SpaceX company has finally brought the heat, the competition needed to give the United States their best. While SpaceX's affiliation with the government might seem sudden, it didn't start that way. It all began with a man who dared to dream, to challenge the old companies like Boeing, who used to champion space travel and the creation of combat and commercial aerial vehicles, while overcoming the high cost of producing rockets, making them reusable and making them safe enough for travel. His name is Elon Musk. Soon he started to get military contracts, earning billions while working with the Pentagon, providing them with a means to launch satellites into orbit. However, the conversation soon moved further than merely launching satellites into the sky, as the Pentagon saw very quickly the potential of Elon's company to create something entirely different from what they used to have, especially since the addition of the behemoth Starship. Now, with Elon's influence in the White House as chief of the Department of Government Efficiency, talks reportedly extended from launching payloads into space for the United States of America to the possible creation of a behemoth bomber that could tower above the United States Air Force bombers like the Boeing B-52 Stratofortress and maybe compete with the Northrop Grumman B-21 Raider. Their rationale was rather simple. Elon is already on the cusp of creating aerial vehicles fast enough to hit Mars by 2026, so why wait for relatively slow bombers which travel at subsonic speed when there is a possibility of Elon creating something faster and relatively more lethal? Although SpaceX has never developed a weaponized combat aerial aircraft, being at the adult table at the Pentagon comes with making tough choices and new decisions, something rather different from a favorite niche. Hence, he reportedly agreed, and SpaceX now stands on the precipice, holding the fate of the United States bomber jets in his palms. Although Elon is a genius, what does he know of warfare to be completely entrusted with creating a bomber for the United States? And how does it supposedly compare to his predecessors, especially the B-52 Stratofortress? However, to understand the gravity of Musk's task, we need to look at his competition, the B-52 Stratofortress bomber. The B-52 Stratofortress bomber is a titan of the Cold War, a behemoth that shows up, and the opposition already knows that it is not going to be a good day. As often reported, Boeing really outdid itself on the Boeing B-52 Stratofortress, as it shattered every conventional assumption and belief about the limitations of bombers in the 1950s. The Boeing B-52 Stratofortress is a long-range, subsonic, jet-powered strategic bomber, meaning that it could hit the target not only from seriously ridiculous heights, but it could also have debilitating effects on the opposition, and they would suddenly break their spirits enough to avoid a full-blown or all-out war. For some context, Operation Linebacker II in 1972 saw the use of the B-52 Stratofortress bomber in strategic warfare in an attempt to reach a quick ceasefire. The operation took place during the Vietnam War, when the United States unleashed the full strength of its air forces, with the B-52 Stratofortress bomber at the very centerpiece. The operation lasted from the 18th of December to the 29th of December, 1972, during the North Vietnamese War. They unleashed more than 20,000 ordnance that was dropped on military and industrial areas in Hanoi and Haiphong, and at least 1,624 civilians were killed. The operation was the final major military operation carried out by the United States during the conflict and the largest bombing campaign involving heavy bombers since World War II, and Vietnam just didn't know what hit them. After the rain of fire from the bomber, their spirits were broken, so they threw in the towel and decided against an all-out as they stood no chance against a bomber. But what makes the B-52 bomber special, and how was it brought into being in the first place? Let's dial back to November 23, 1945, when the AMC, otherwise called the Air Materiel Command, issued desired performance characteristics for a new strategic bomber that could be used as a long-range bomber without needing a base on foreign grounds, which may be controlled by other countries. They wanted the aircraft to travel at least 34,000 feet, with a crew of 5 or more working the gun turret and a 6-man team that will be working as a relief crew. However, as is popular with a combat aerial vehicle, the ordnances and bombs it carries as payload are of grave importance. What's the point of a bomber jet without enough payload to send anyone running? So they asked for an unspecified number of 20mm cannons and over 4,500 kilograms of bombs. The United States Air Force immediately sent out a bid invitation, inviting all the heavyweights of America's aircraft companies, including Boeing, Consolidated Aircraft, and Glenn L. Martin, to submit proposals. Eventually, Boeing won the 3-horse race and called and got a massive $1.7 million to build a full-scale mock-up of the XB-52 and do preliminary engineering and testing. However, they had trouble at first meeting the specification until much later, when they finally created the B-52 version, with the perfect size and ability to take on payloads. B-52 Stratofortress was designed to have swept wings, potted jet engines, and also crew ejection systems in case of a crash, or if it ever happens that they encounter anti-aircraft resistance strong enough to shoot down the aircraft. However, there are different versions of the B-52 with a little bit of difference in their structural designs. For example, on the B-52D, the pilots in the electronic countermeasure team are ejected upwards, while the crew on the lower deck are ejected downwards. However, the tail gunner, who was stationed at the rear end of the bomber jet, had to manually jettison the gun turret before they then crawled out through the opening, making the survivability percentage extremely low. Enter the B-52G, which was released August 31, 1958, as a potential successor to the B-52D. The G version was stronger and better, and the survivability percentage for whoever manned the gun turret was increased by well over 60%, as they could now eject like everyone else. Although the survivability of the crew has been protected by the changes made to the placement of the gun turret, the aircraft still had a common problem: structural fatigue. In material science, fatigue is the initiation and propagation of cracks in a material due to cyclic loading. Once a fatigue crack has initiated, it grows a small amount with each loading cycle, typically producing striations on some parts of the fracture surface. In the aircraft, the fatigue was accelerated by low flying, 8 times more than it was affected when it was flown higher in the sky. For some context, flying really high in the sky is much easier, as there are fewer needs for sharp turns or a need to zoom faster. However, when they fly too close to the ground, there is a need to turn sharper, focus on maneuvering around rocks, and really work the body of the bomber jet. The metal starts to get tired, it cracks, and in some rare cases it bends almost out of shape, requiring the need to fix the plane. The classic wear and tear was starting to make the bomber jets difficult to use for more than 2,000 hours of flight. So in the early 1960s, the United States Air Force created the high-stress program as some sort of checkup program for every B-52 bomber that had been in the sky for over 2,000 hours and was surely going through some structural fatigue. Once they look through the B-52s that had flown over 2,000 hours, they check which one needs to be fixed, and they have stronger pieces added to the body of the bomber, giving it a bit more leverage to fly for that long. As time went on, the Air Force got even craftier, with the creation of wet wings attached to their G and H models of the B-52s. They were called wet wings because they were capable of holding way more fuel than the other models. However, that compromised the structural integrity of the bomber jet even further. The added weight on the wings from the fuel forced the wings to bend out of shape, and they got 60% more fatigue than the B-52D. Once again, the need arose for a solution, so they created the ECP-1050 as a replacement for the wet wings, which increased the durability of the jets and reduced the percentage of quick wear and tear. But there was something more about the bomber, as its sheer size meant that it couldn't perform huge spins or a loop-de-loop like a fighter jet could at an aviation show or in combat. Although the yaw, pitch, and roll were added parts to the bomber plane, it was not built to move like a stunt plane. Instead, the flight controls were focused on vertical stability, even though it has a relatively small, narrow chord rudder, giving it limited yaw control authority. It was almost like having a giant school bus in the air, big, powerful, and with enough room to carry people and ordnances. However, by 1977, they conducted a pacer plank reskinning. The structural fatigue while moving at Mach 1 speed, which is subsonic, was a message to the United States Air Force to make a change. But the United States Air Force continued instead to rely on the jet for its services during war, especially because of its armament as a bomber plane, which is much better than its predecessors. The bomber plan was optimized to carry up to 20 Boeing AGM-69 SRAM nuclear missiles, which are air-to-surface missiles with a nuclear warhead. It had a range of up to 110 nautical miles and was intended to allow United States Air Force strategic bombers to penetrate Soviet airspace by neutralizing surface-to-air missile defenses. It was the perfect response to surface-to-air missiles because it was easier to direct, owing to its precision systems. In a bid to further improve its offensive ability, Air-launched cruise missiles, or ALCMs in popular military parlance, were fitted into the B-52 bomber jet. However, after testing of both weapons of mass destruction, the United States Air Force-backed Boeing AGM-86 air-launched cruise missile and the Navy-backed General Dynamics AGM-109 Tomahawk, the AGM-86B was selected for operation by the B-52. However, the continuous development of more models of the B-52 Stratofortress, the Conventional Enhancement Modification, or CEM program, gave the B-52H a more comprehensive conventional weapons capability, adding the modified underwing weapon pylons used by conventional armed B-52Gs, Harpoon and Havnap, and the capability to carry new generation weapons including the Joint Direct Attack Munition, or JDAM, and Wind-Corrected Munitions Dispenser guided bombs, the AGM-154, glide bomb, and the AGM-158 JASSM missile. While the B-52 remains a legendary bomber, the times have changed and technology is moving on once again. Although the B-52 bomber remains in use by the United States Air Force when needed, the Northrop Grumman B-21 Raider has come to take its place in the United States Air Force, and the world's about to be introduced to it. But what makes the Northrop Grumman B-21 Raider special enough to become a welcome addition to the new Air Force fleet? The Northrop Grumman B-21 Raider is another masterclass strategic bomber plane being developed in the United States. It is being developed at the behest of the United States Air Force as a part of the Long Range Strike Bomber, or LRSB program, but this time it is a complete upgrade on what the B-52 Stratofortress was capable of. Imagine a bomber jet capable of stealth operations and the ability to deliver conventional and thermonuclear weapons. Well, with the Northrop Grumman B-21 Raider, no one has to imagine anymore. The classified program started in 2011 when the United States Air Force decided it needed a faster bomber plane with more range. So, as is usual practice, they reached out to the heavyweights in the game, offering them a development contract, which was eventually awarded to Northrop Grumman in October 2015. Of course, every company wanted to be in charge of the future of the Air Force fleet, but someone had to win. This time, it was Northrop Grumman. However, a civil war ensued, with Boeing and Lockheed Martin, who submitted losing bids for the project, filing bid protests, claiming they had been wrongfully overlooked for Northrop Grumman. In October 2016, the Government Accountability Office, or GAO, rejected the challenges and sustained the United States Air Force's decision to award the LRSB contract to Northrop Grumman. The Government Accountability Office report revealed that cost was the deciding factor in selecting Northrop Grumman over the Boeing Lockheed Martin team. The Air Force set up an uphill task for Northrop Grumman, telling them that they needed an addition of intelligence gathering, battle management, and interceptor features to the bomber, and a fifth-generation global precision system that guides the release of bombs, nuclear warheads, and all types of payloads it might be carrying. However, alongside India, which is on the cusp of unleashing its sixth-generation aircraft, albeit a fighter jet, the United States is closing in on releasing the first-ever sixth-generation aircraft, but this time, a bomber jet. Fast forward 5 years after it was commissioned to Northrop Grumman, and the Air Force released new renderings of the aircraft, showing a smaller and lighter design than what is typically expected from a bomber. The sheer reduction in size and distinctive flush in blended inlets, with the two-wheel landing gear design, was a revelation of something never seen before. The drawing shows a smaller and much lighter aircraft than its predecessors, like the B-2 and the massive subsonic B-52 Stratofortress. The world had finally had a glimpse at the possibility of the future of bomber planes, with a huge reduction in size being a topic for discussion. However, just a year later, Darlene Costello, the acting Assistant Secretary of the Air Force Acquisition, Technology and Logistics, confirmed that the first two B-21s were under construction at Plant 42. D-Day came on December 2, 2022, when the first-ever B-21 was unveiled at the Northrop Grumman production facilities in Palmdale, California. At the unveiling, Northrop CEO Kathy Warden said that the B-21 is designed with modular, open systems architecture to allow easy upgrades and, potentially, the ability to export components to foreign buyers. The open systems architecture wasn't particularly the most popular form of building jets in the past, especially when a Cold War hero like the B-52 Stratofortress was built. Boeing at the time had relied heavily on the importance of closed architecture systems, which made fixing and upgrading the early B-52s a nightmare for mechanical engineers who had the pleasure. The open systems architecture is more like building up a Lego character, and all that needs to be done for a quick fix or an upgrade is to simply remove and replace without a need to tear apart the whole structure in the name of rebuilding. On the flip side, the closed structure system is a packed and sealed deal. A fix would need a complete deconstruction of the object before being rearranged, regardless of how massive or small the problem is. Although the popular reasoning is to view the very first tested aircraft as a prototype, the test aircraft was not deemed as one. Rather, it will be converted to operational configuration by the Air Force after the test flight has been completed. In 2023, the officials of the Long-Range Bomber Program revealed that the fueling and engine tests took place at the end of the year and were successful, leading to the approval of a low-rate initial production, or LRIP, contract being awarded to Northrop Grumman in January 2024, meaning that there would be a small batch of B-21 Raiders in the production phase and about to be released in 2025. However, new speculations about Elon Musk, the Tesla and SpaceX boss, creating a behemoth bomber of his own, sanctioned privately by the Pentagon, seem not to be going away. A shocking tale despite the news of the imminent release of the B-21. Although the mystery remains nail-biting and fairly disturbing, as there are no signs of signed documents or public articles that are published to that effect, the speculations remain intact, with specifications of a possible sixth-generation SpaceX bomber capable of a direct lift off the ground and possibly carrier-based, and also due to be released the same time as the B-21 Raiders. Whether Elon Musk's clandestine arrangement to release a SpaceX bomber in 2025 is real or other media noise, only time will tell. The world is on the brink of witnessing a groundbreaking achievement in aviation history. The United States military has teamed up with SpaceX on a top-secret hypersonic aircraft project that promises to redefine the limits of air travel. With SpaceX's innovative technology and the military's expertise, this partnership is set to create something once thought impossible. What exactly does this collaboration entail, and how will it change the future of aviation? Join us as we explore the details of the secret hypersonic aircraft that the U.S. military and SpaceX partner up for. The United States Department of Defense is reportedly interested in a bold new partnership with SpaceX, aiming to use the massive Starship rocket for its own high-stakes missions. According to Aviation Week, the Pentagon has proposed flying Starship as a government-owned, government-operated vehicle, giving the military full control over the spacecraft for particularly sensitive or dangerous operations. Currently, SpaceX works with the DoD as a launch service provider, where the company handles the logistics and operation of its rockets. However, this new arrangement would shift that dynamic significantly, allowing the Pentagon to take over the Starship system entirely. This move shows the growing importance of Starship's unique capabilities, such as its ability to carry heavy payloads and potentially perform rapid deployments anywhere on Earth or in space. By owning and operating Starship, the Department of Defense could explore a range of missions, from quick response logistics to advanced space-based operations, underscoring the rocket's potential as a game-changer for national security. This shift also reflects how government agencies are increasingly relying on cutting-edge commercial technology to achieve strategic goals. This is not the first time the United States would partner with SpaceX. In 2023, SpaceX's Falcon Heavy rocket launched the USSF-52 mission into orbit from Florida's Launch Complex 39A. This mission includes the X-37B, a small space drone about the size of a bus, which resembles NASA's retired space shuttles. On its seventh journey, the X-37B performed advanced tests such as studying radiation effects on materials for NASA and exploring new orbital zones. This marks the first time the X-37B has flown on the powerful Falcon Heavy, capable of carrying massive payloads deep into space. The reusable drone, designed by Boeing and Lockheed Martin for the Air Force, has been in operation since 2010. It runs on solar power and has previously tested how radiation affects seeds and materials. The launch came shortly after China sent its secretive robotic spaceplane, Shenlong, into orbit for experiments and reusable technology tests, emphasizing peaceful space exploration. But that's not all. The Space Force's mysterious spacecraft is trying out an exciting new trick. The Space Force announced that the spacecraft will attempt a groundbreaking technique called aerobraking. This involves using the drag of Earth's atmosphere to adjust its orbit, saving precious fuel in the process. This announcement is unusual because the movements of such classified spacecraft are typically kept under wraps. By revealing this experiment, the Space Force highlights the impressive capabilities of its high-tech space program, sparking curiosity about what else this secretive craft might be able to do. This is the first time the X-37B, or the Space Force, has tried such a maneuver, showcasing the growing sophistication of space technology. Interestingly, this technique might feel familiar to fans of the 2014 sci-fi movie Interstellar. In the film, Matthew McConaughey's character, Joseph Cooper, uses a similar method to land on a distant planet without burning extra fuel. By attempting aerobraking in real life, the X-37B is pushing the boundaries of what's possible in space exploration, turning science fiction into reality. According to Air Force Secretary Frank Kendall, the Space Force is also breaking new ground with a series of smart and efficient maneuvers, showing its dedication to innovation during critical national security missions. The move is more than just a technical feat. It's a big step toward responsible space operations. The Space Force announced that the importance of using the advanced aerobraking technique is to safely dispose of unnecessary parts from its X-37B spacecraft. Instead of leaving debris in a higher orbit, where it could linger for years and risk colliding with satellites, the team is ensuring everything is disposed of according to strict space debris guidelines. This decision shows the growing global concern about space junk, especially after incidents like Russia's satellite breakup in June, which created over 100 pieces of hazardous debris. Todd Harrison, a space policy expert at the American Enterprise Institute, praised the Space Force's efforts, saying it sets an example for commercial companies, governments, and other nations. Harrison explained that they are showing how responsible space operators should act. Don't litter if you can avoid it. While aerobraking is a common practice for NASA and private companies, this marks the first time the Space Force has attempted it with the X-37B, a top-secret spacecraft it has operated since 2020. Harrison added that this move isn't about taking risks but about gaining confidence in the spacecraft's capabilities and exploring what it can achieve. This bold step by the Space Force to push boundaries and explore new possibilities with the X-37 reflects the same adventurous spirit that has driven pioneers in space exploration. Speaking of trailblazers, few have captured the world's imagination like Elon Musk. So how did his fascination with space exploration begin? During a trip to Russia, Elon Musk was so insulted by the way he was treated that it changed the course of his life. He had gone to negotiate a deal to buy rockets for a planned mission to Mars, where he dreamed of creating a greenhouse called Mars Oasis. However, the dismissive behavior he encountered sparked his determination to compete with Russia instead. Former NASA Deputy Administrator Lori Garver described the moment in her book, comparing it to the legendary story of Helen of Troy. If Helen had a face that launched 1,000 ships, this was the spit that launched 1,000 spaceships. Musk founded SpaceX less than a year later in 2001, turning it into a major player in space exploration. Over the years, SpaceX has become a fierce rival to Russia's Soyuz rocket, solidifying Musk's reputation as a game-changer in the space industry. SpaceX co-founder Jim Cantrell and author Ashley Vance have also highlighted this pivotal moment in documentaries and Musk's biography, showing how one insult fueled Musk's bold vision for the future of space travel. Elon Musk named his first rocket Falcon as a tribute to the Millennium Falcon from Star Wars. Falcon 1, a two-stage rocket designed for orbital launches, cost around $100 million to develop. A year later, SpaceX introduced its second spacecraft, the Dragon, inspired by the song Puff the Magic Dragon. Musk chose the name as a playful nod to skeptics who dismissed his ambitious space plans as fantasy. At the time, SpaceX was one of the few companies daring to build commercial space rockets. Musk, fresh off the success of PayPal's sale to eBay, invested a third of his fortune into the venture by 2006. NASA also supported the company with $278 million through its Commercial Orbital Transportation Services program, while the Department of Defense funded the first 2 Falcon launches. What began as a bold gamble quickly set SpaceX apart as a leader in the new age of space exploration. That same year, SpaceX's first rocket launch ended in failure due to a fuel leak and a fire caused by a corroded fuel line nut damaged by ocean spray. To fix the issue, SpaceX switched from aluminum hardware to stainless steel in its rocket design. Despite the improvement, the next 2 launches also failed. The rockets successfully completed the first stage, but couldn't make it to orbit after stage separation. These setbacks nearly bankrupted SpaceX, putting the entire company on the brink of collapse. At the same time, Elon Musk was struggling to keep Tesla afloat, facing enormous financial pressure. According to Eric Berger's book, Liftoff, Musk was so overwhelmed by stress that he often woke up from nightmares, screaming and in physical pain. These early failures tested Musk and his companies to their limits, but they also laid the foundation for SpaceX's eventual rise as a leader in space exploration. On September 28, 2008, SpaceX made history with the first successful launch of its Falcon 1 rocket from Omelek Island in the Marshall Islands. This marked a groundbreaking moment as it was the first privately funded rocket to reach orbit, breaking the dominance of government-run space programs and proving that private companies could compete in the high-stakes space industry. Interestingly, SpaceX made no major changes to the rocket's design between its 3rd and 4th launches. Instead, they adjusted the timing between the first stage burnout and the second stage separation, addressing the issue that caused the previous failure. In a 2-stage rocket like Falcon 1, the first stage, or booster, provides the initial powerful push before separating, while the second stage takes over to carry the payload into orbit. Elon Musk later reflected on these tense times, admitting in an interview that he messed up the first 3 launches all by himself. The 4th launch was their last chance. If it had failed, SpaceX would have been done. But fate smiled on them that day. The success of the 4th launch was a game-changer. It not only saved the company, but also helped SpaceX secure additional funding from NASA and private investors, giving it the financial stability needed to continue innovating. The Falcon 1 rocket, having proved its worth, was retired after its 5th and final launch in 2009, paving the way for more advanced SpaceX rockets like the Falcon 9. This milestone wasn't just a victory for SpaceX. It reshaped the space industry, opening the door for private companies to play a significant role in space exploration. SpaceX has achieved incredible milestones in space exploration, starting with its Dragon 1 spacecraft. In 2012, the Dragon 1 became the first commercial spacecraft to deliver cargo to the International Space Station, a historic moment that led to several more contracts between NASA and SpaceX. Interestingly, Dragon 1 completed 23 cargo missions to the ISS before being retired in 2020. Meanwhile, SpaceX began developing Dragon 2 in 2014, a more advanced version designed to carry both astronauts and cargo, marking another step toward revolutionizing space travel. However, SpaceX's journey wasn't without challenges. In 2015, disaster struck when a Falcon 9 rocket exploded just 2 minutes after liftoff while carrying supplies to the ISS. The cause was traced to a steel strut holding a helium pressure vessel that broke under the launch's intense forces. Another failure occurred in 2016 when a Falcon 9 exploded during a pre-launch static fire test. These setbacks tested the company's resilience and commitment to innovation. SpaceX bounced back later in 2016 with a groundbreaking achievement, successfully recovering the first stage of a Falcon 9 rocket on a drone ship in the Atlantic Ocean. This recovery was more than a technical feat, it was a game changer. Reusing rocket stages reduced SpaceX's cost by about 30% according to Musk. By 2017, SpaceX began offering payload launches on reused rockets at a 10% discount, further proving its ability to innovate while saving costs. In a bold mix of ambition and whimsy, SpaceX launched a cherry red Tesla Roadster into space in 2018. Behind the wheel was Starman, a mannequin dressed in a futuristic SpaceX spacesuit. Musk called it the silliest thing we can imagine for a test payload, and it turned out to be just as iconic as practical. The car is still speeding through space, making it the fastest sports car ever. a dedicated website, whereas Roadster.com tracks its incredible journey. As of December 20, the Roadster was over 200 million miles from Earth, zooming away at an astonishing 6,473 miles per hour. SpaceX didn't stop there. This company achieved a groundbreaking moment in 2020, reigniting human spaceflight from U.S. soil after nearly a decade. On May 30, the Crew Dragon spacecraft, atop a Falcon 9 rocket, carried astronauts Doug Hurley and Bob Behnken into orbit. It was the first time humans had flown on a SpaceX rocket and the first U.S. launch of astronauts aboard a new spacecraft since the Space Shuttle's debut in 1981. This milestone was part of NASA's Commercial Crew program, which aimed to develop private spacecraft for crewed missions. Later in 2020, NASA certified SpaceX's Falcon 9 and Crew Dragon system, ending the United States' dependence on Russia's Soyuz rocket for transporting astronauts to the International Space Station. SpaceX's Starship project represents an even grander vision, settling Mars. In May 2021, Starship achieved its first suborbital test flight without exploding, marking a significant step toward Musk's dream of building self-sustaining colonies on the Red Planet. Starship, paired with the Super Heavy booster, is designed to be a fully reusable rocket system. This ambitious design aims to drastically cut space travel costs by a factor of 100 or more, according to Musk. NASA has also selected Starship for its Artemis program, intending to land astronauts on the moon for the first time since 1972. The road to success hasn't been smooth. At SpaceX's Texas facility, early Starship prototypes often met fiery ends, exploding during flight or failing to land safely. But the fifth prototype finally landed intact, proving the feasibility of reusing the rocket's second stage. Now SpaceX is focusing on sending Starship into orbit with the Super Heavy booster. While the date for this monumental test flight remains uncertain, it represents a giant leap toward making Mars colonization a reality. From launching a Tesla into space to building rockets for Mars, SpaceX continues to redefine what humanity can achieve among the stars. SpaceX made another daring leap toward the future of space exploration with the launch of its colossal Starship rocket on Thursday. Powered by the massive Super Heavy booster, the uncrewed rocket lifted off smoothly and soared into the sky, marking an incredible first for the ambitious spacecraft. For nearly 3 minutes, everything appeared to go as planned, with the rocket blazing a trail through the atmosphere. However, things took a turn when Starship was supposed to separate from the booster and continue its journey into orbit. Instead, the rocket began spiraling out of control, leading to a fiery explosion. SpaceX engineer and livestream announcer John Insprucker humorously referred to the incident as a rapid, unscheduled disassembly. Despite the outcome, the event was far from a failure for SpaceX. This was the first time the Starship and Super Heavy booster launched together, and even reaching liftoff was a significant achievement. The plan was for the rocket to spend about an hour at orbital altitudes before splashing down in the ocean. But SpaceX engineering manager Kate Tice noted that clearing the launch tower alone was a major milestone. Elon Musk, SpaceX's founder, remained optimistic, calling the launch exciting and congratulating his team. Musk had been upfront about the challenges, stating beforehand that the launch had only a 50% chance of success. Yet the attempt pushed the boundaries of what's possible and provided valuable insights for the next launch. Starship is central to Musk's vision for the future. Designed to carry humans and cargo to the moon, Mars, and beyond, it represents the next frontier in reusable rocketry. With every test, including this one, SpaceX is learning and improving, inching closer to making space travel more accessible and affordable. While the explosion might grab headlines, the bigger story is about determination and innovation. For SpaceX, even setbacks are steps forward on the path to reaching the stars. As Musk and his team gear up for the next attempt, the world watches with anticipation for what's next in this thrilling journey. In September 2021, billionaire Jared Isaacman led a groundbreaking space mission unlike any before. He and 3 other civilians boarded SpaceX's Crew Dragon Resilience, launching atop a Falcon 9 rocket for a 3-day adventure in orbit. This historic flight marked the first time a crewed mission went to space without any professional astronauts. Even more inspiring, the mission had a heartfelt purpose: raising funds and awareness for St. Jude Children's Research Hospital. The effort brought in over $243 million, making it a journey of both discovery and generosity. SpaceX, the company behind this incredible mission, has been smashing records for over 20 years. Last year, it set an extraordinary milestone with its Falcon 9 rocket achieving 101 flawless launches in a row, the longest streak for any single rocket type. By October, SpaceX set another record, completing 48 Falcon 9 launches in just 10 months. This streak highlighted SpaceX's reliability and efficiency as it continues to push the limits of space exploration. As one of the most valuable private companies in the world, with a valuation exceeding $100 billion, SpaceX isn't just aiming for the stars, it's reshaping what's possible in spaceflight. Whether inspiring charitable missions or setting records, SpaceX proves that the future of space travel is brighter than ever. Despite his success in space exploration, Elon Musk has been labeled a far-right activist and even called a threat to democracy. Through his ownership of X, he's waded into global political disputes, sparking controversies from Brazil to Australia. He's also filed lawsuits aimed at silencing critics. His involvement in the Russo-Ukrainian war also became a global conversation. His Starlink satellite system, originally provided to Ukraine, has now been widely adopted by Russian forces, significantly improving their communication on the battlefield. While Starlink initially aided Ukrainian troops, Russian units have increasingly acquired the terminals, enhancing their operational coordination. This shift has transformed Russia's combat effectiveness, enabling better communication and more precise coordination. The use of Starlink has notably influenced key battles like the fall of Vuhledar. This development raises concerns about SpaceX's role in preventing enemy access to the system, especially when both sides operate in close proximity. His involvement in politics goes deeper than that. During the 2024 United States presidential race, he publicly backed Donald Trump and supported a key political action committee that aided Trump's re-election. Now he's playing a major role in shaping the next administration, with President-elect Trump appointing him to help lead a Department of Government Efficiency. This advisory group will collaborate with the White House and Congress to streamline and downsize the federal government. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.